Welcome to SurrealDB Stream, all about Python. Great to have you here. Let us know where you're calling in from or watching from. Got a couple of people on YouTube, a few more on LinkedIn. Brilliant to see you all. And we've got some exciting stuff today about Python, the new library we're going to be releasing very soon, and kind of what the future means for SurrealDB and Python and what you'll be able to do with it. So really exciting stuff today. I'm joined with Alexander, our data evangelist. He's going to be talking about how SurrealDB's new Python integration can be used for big data and working with inside Python. And then I've got Maxwell who joins us. He's been working on the new Python integration with Rust, which is really exciting. So we've got people from Vienna, Austria. Welcome, and Miguel, great to have you here as well. And 78 Woosley, hello. Awesome. So let me turn this music off now. Excellent. So Alexander, Maxwell, welcome. I guess the big question is why are we doing a stream on Python? Because what's new, what's different, and what's exciting?
Yeah, I think to start with, let's kind of like talk a little bit about how we've kind of been evolving the client libraries as we've kind of been starting. When SurrealDB started, it wasn't engineering resources because it was just Tobie to make all the client libraries. So we have had an amazing community that has been actively contributing client libraries in different languages, and one of them was Python. And then once the team started growing, we started taking care of more of these client libraries in-house. And so that was originally when I kind of took over the kind of maintainership of the Python library and tried to kind of like standardize it a little bit and tried to kind of like make it align with how other things work. And now Maxwell joined and kind of like making it super robust and like super kind of like performant and kind of like making it ready for our production release.
Awesome. Yeah. So I guess that leads on to the question, which is, this is more reliant and reliable that you just mentioned, and more performant. But Maxwell, what is the big difference between what we're releasing soon, what's cooking in the oven, as it were, and what we currently have as our Python library?
So what we're doing right now that we're hoping to release quite soon is we're fusing Python with Rust. So essentially what we're doing is we're using Rust code natively in the client, and we've got some Python bindings using the PY03. So the user kind of imports the object into their Python code. They make a call, but then it makes a call directly to our Rust code, and then our Rust code constructs the request and makes the connection, and then handles the response. So that's like we get the safety with Rust, we get the speed, we get the compilation in that sense.
So we have the compilation, we have the speed, we have the performance, we have that reliability. But what can we do now, or what will we be able to do with this new release that we couldn't actually do with the Python only library?
So we'll be able to actually use all the features that were in the Rust client that, whereas kind of like Python doesn't directly translate to Rust. And right now we're building it with blocking because a lot of code for Python is blocking. But then we're also moving over to potentially supporting async. And I've tested it around. We can actually use the Tokyo async runtime, which has like multiple threads, or you can have multiple processes on one thread compared to Python, which kind of has the issue with the global interpreter lock. People kind of struggle with that. It's obviously not as performant in that sense.
Awesome. So Alexander, I mean, this is exciting stuff, big changes. It'll lead us to be able to do more integration with Python itself, but also using SurrealDB embedded within Python, actually running within the Python environment. What's the most exciting difference between what the current, let's call it native Python, and an actual native Rust plugin built for Python? What's the difference, and what's the most exciting thing for you?
Yeah, I think it is very interesting, because if we think about what's been happening in the kind of like broader data space, you have these kind of big tools, like for example, say pandas, and you have other tools, and then you have like essentially Rust equivalents of them. So like for pandas, you have polars, which kind of has what you would expect, like the functionality, but it kind of like adds more kind of what you could call performance to it, reliability, all these kinds of things. But so you can see it in the broader kind of like data community, where things are moving towards like Rust being introduced as kind of like a foundation. And what they will enable for us specifically with Python is that you can essentially have the SurrealDB inside the kind of like the Python runtime, if you will, which opens up a lot of opportunities. For example, you'd have use cases where we'd use like SQLite before. That'd be very interesting. But imagining you'd have, instead of having SQLite, which is amazing at what it does, but you have a lot more flexibility in terms of what you want to do, and specifically having access to all the functions that we do in SurrealDB that can enable your Python product. So for example, if you take a concrete example, you could have a machine learning pipeline using data from SurrealDB, and then you could actually use a lot of the cool functionality that we have, say for example, live queries or other types of things, where you could be having this kind of like continuous retraining of data. There are also more examples where, with our the way we handle events and the way we kind of able to create metrics, so you could effectively have a kind of like semantic layer on top, like in your database, not on top of your database, therefore reducing some layers, and you can kind of like directly communicate with that in the Python. And so effectively what this will do is allow us to kind of have things be less complicated, because when we're talking about analytics, or we're talking about AI, machine learning, there tends to be a lot of infrastructure around it, and this infrastructure is often in like Kubernetes and all these kinds of things, which people don't necessarily want to set up. But having it kind of like embedded means that you don't have to wrangle all the infrastructure. You kind of like have everything up and running.
Yeah, that's awesome. You mentioned connecting over WebSockets and storing, taking data from the database, kind of analyzing it, maybe using it in machine learning, data science, and then pushing that back into the database potentially. I think we've got a question here from Miguel, which is, can we use this in with AI/ML, and are we able to add plugins and use pandas around SurrealDB within the within Python? I think the other thing to make clear would be, this would actually enable you to use SurrealDB within Python without ever connecting to a remote database. So you store data inside Surreal, you analyze it, maybe using graph, or maybe you're just storing document data, and then you're able to pull that data out, or maybe push more data in, and you never actually have to leave the process of Python. You never have to connect to an external data store if that's what you want. I know Maxwell's got some stuff he's been working on for the tests in building this, which is all around Flask and running SurrealDB as a data store for a web server, effectively. So it'll be great to get onto that and just show it another use case, or yet another use case that SurrealDB can be using, which is really exciting. So we've got another question here actually from a LinkedIn user. I'm not sure the name because it doesn't come through from LinkedIn, but they've asked, would schema enforcement be possible with Python? So I think that probably is good to clarify exactly what that difference is and what that means with the Rust build of the Python library. And that it is actually the entire database sitting within Python here. So everything that we're working on in the database, whether that is improved schema, improved typing, the functionality around the query language with graphs and time series, all of that is actually available right within Python, not connecting to a remote database in the cloud, but actually sitting within Python itself. So really exciting stuff. Let's get a kind of demo on what we can do with this, and Maxwell also in due course. Let's bring up the Flask server just to show, connecting to SurrealDB within Python and using it as a server. Alexander, let's bring up your screen.
Oh yeah, I'm sorry. I thought you meant Maxwell. No problem. All right. So for those who are not familiar, so you can install it here. The current version is just pip install SurrealDB, and once we have the kind of Rust version out, it will just be the same process. And on the main here, you have the current library. And then if you want to take a look at the Rust version, we have that in a branch right here. And Maxwell will look at that in a bit. So in the current Python, it is async. But as we said in the beginning, this will change with the Rust rewrite. We will be making it synchronous. So here in the in the current Python version, you simply import SurrealDB, and you can run it both as a script with a main function where you're essentially signing in, you're creating some data, updating it, selecting it, and whatnot. And you can, of course, just run that. And then we also have the option for you to use it as a notebook because, of course, when it comes to Python analytics use cases, often the case you want to use it in notebooks. And we have these kind of methods, which broadly are like the CROT methods. But then if you want to execute arbitrary code, or you want to execute like arbitrary SQL or SurrealQL, we also have the query method, which allows you to do all the things we can do with the methods, but also more things. As you can see that here.
Yeah, that's awesome.
Mm-hmm.
And how, just so everyone knows who's watching this, how is this actually running? Is this running locally?
Yep. So this is running locally. So here I'm connecting to localhost, and then I'm running a local SurrealDB server.
Awesome. And then the notebook, that is actually how does that work?
So this notebook is essentially just a very simple IPython notebook. You can have it in Jupyter Hub, or you can use the standard VS Code notebook like I'm using at the moment. So effectively have a lot of flexibility of where you want to run it, whether you want to have it as a script, as a notebook, or as Maxwell will show later as a Flask server.
Awesome. I guess that brings, you mentioned async and non-sync, and Maxwell mentioned that slightly earlier. We're talking about what we're building in Rust. I guess that leads us onto the question, what's the difference between async and sync? in Python? What are the different ways people use it, and what does that mean? What does that result in?
So in terms of like async, so when you have something that's blocking, your code will just execute as and when, and this can be like quite bad when you're having something like a HTTP request or a connection to a database, because your CPU isn't really doing anything, right? It's just kind of waiting for a callback. So async, in a high-level sense, is basically having a feature and polling it. So you send a request to a database, then you chuck that feature back onto the queue, and you start polling other features as well, or other tasks, depending on how you want to classify it. And then when it's ready, you'll come back and you'll say, okay, we're ready and we're done. And you can continue with that execution. So it's a much more kind of like efficient way, because it's kind of like dead CPU time. So if you think about, like, let's say we have 2 HTTP requests at the same time, if we do them in an async manner, we just still have one thread, and we just keep checking on those 2 HTTP requests to see if they're actually finished. So we can run them, so we can essentially half the time, and this scales very well if you have like multiple requests. And in servers, you have like multiple requests, obviously. So on the server side, this becomes very powerful. The difference between async in Rust and the difference between async in Python is that Python really is just kind of locked with one thread. And if it tries to spin off another thread, it's kind of blocked by what we call a global interpreter lock. So it's not really that performant. Whereas Rust kind of can have, like, let's say 2 threads, and it can be processing both at the same time CPU intensive tasks as well. So it's insanely more performant. And we see this with, let's say, the Rust servers. They're just very, very performant. Python servers don't completely fall apart, because you have something like a Gunicorn or a WSGI, which is kind of like a process that kind of sits in front of the server, has a couple of workers. It sets the requests in a queue and then starts passing them through to the server. So it doesn't mean that you can't use Python. It just means you have to do extra steps in those things.
Awesome. So we've got a question here from LinkedIn asking, would this be suitable for event sourcing microservice architecture? And is it, with the new API, is it ACID compliant? And I guess who wants to talk about either of those things?
I guess, Alexander, you're more on this stuff like ACID compliant, I guess.
Yeah. So effectively, when you thinking about like ACID compliance, it's about the database. So effectively, if you're having half of your logic in the Python and half of your logic in a database, you might run into problems, because ACID is essentially, we're guaranteeing ACID in the database. So the queries that you send over are ACID compliant. But if you're having half of your logic in Python, and then like half of your logic in a database, then there might be some inconsistencies. But when it comes to the kind of like microservice architecture, yes, you can definitely use Python for that if that is performant enough for your use case. And there's also a very interesting example for kind of like IoT services, as you can, as we mentioned earlier, you have like a full database inside Python. And so, for example, if you're running a Raspberry Pi somewhere, or somewhere where you can install Python, then you can have a full database that is like very powerful. That is very powerful. That can collect this information. So there is a lot of potential for that.
Interesting. I guess other uses are caching layers and things where your database is kind of being used just in that process in Python, and not really, the data isn't really escaping that process, but you need to analyze and store and query that data. Is another interesting take. I've got a statement actually from Vikas on LinkedIn. He's saying they're currently using Flask and also considering Fast API in the future, and SQL Alchemy and SQL Model in the future as well. I guess that's kind of nicely introducing us into what Maxwell's going to be demonstrating in a bit, which is the new Rust Python bindings and linking it with Flask and Conicorn and for our tests. But it also leads us to a question, which is kind of what is the plan for this going forward, and how what other features do we have planned, and how do the community get involved?
So the first plans are essentially just to get the Rust infrastructure, the Rust client kind of working and compiled. So we are now going through this process of, right now, at this stage, if you were going to install it off that branch today, you would need Rust installed because you need to actually compile the client. So we're kind of going through building our own wheels with pre-compiled binaries. So we don't have to have, Rust installed. But this doesn't actually stop you from using it today. And I will go through some of the files that we've got in terms of you can do 2-layer builds in Flask and actually use it, but it's still, an unstable branch, I would stress in that sense. There are some people here that are talking about schema enforcement. There is a way in which I guess we could support a third-party module, being built as a kind of ORM. But we've got quite a lot to do in terms of, SurrealDB is much more than just like sending database requests. We have like WebSockets, we have events, that sort of thing. We want to make sure that kind of works really well. But there could be some, community base where we can build kind of like schema objects, because if you have this Python object that can translate from JSON to the Python object, then that's very achievable. So someone here was talking about SQL Alchemy. SQL Alchemy is quite a big, ORM. And if you wanted to try and mimic that, you just have like a Python object that's kind of like a DB model, and you'd have another Python object that is a field object. And then you'd have a JSON serialization and deserialization for that. So you'd loop through and have does it have an attribute of, when you go through each attribute, when you loop through, is it an instance of a field? And then you can serialize it or deserialize it to JSON. So it's doable, like what's happening with SQL Alchemy under the hood isn't magic. This is quite a possible thing. But at this point in time, from what I understand, and obviously people can correct me on this, is that we're going to be focusing on making sure the core infrastructure of the events, the bidirectional WebSockets, this sort of thing, the authentication is all working first. So if someone is itching to have some sort of model mapping, we can then, you can message me and I can give you some pointers and give you some advice and stuff on how to do it. And it is doable, but it's not something we'll be directly working on.
Mm-hmm. Yeah, regarding the ORMs like SQL Alchemy and others, it kind of is interesting because you have, of course, ORMs in general, which stand for object relational mappers, and the kind of like the key thing there being relational, and so they work currently best with relational databases. Then you have like ODMs, which is like object document mappers, like for example for MongoDB and so forth. And we actually support a range of data models. And so if it was just a matter of just plugging in, it might be easier. But then the range of kind of querying possibilities that we support is something that takes some consideration to put into an ORM.
I think that also leads us on to the point that was made quite a while ago on our Discord, which is the API around Surreal and the way that you can query records immediately without having to use indexes or without having to select all from a table. It leads it to being used effectively in a very similar way to how an ORM is used in the first place. You have the create statements, the update statements, the the relate statements in the API. Now you can always go a step further and use the query functionality, but it definitely is different to how you would normally query a relational database or even a document database. You're not having to select all from table where ID equals this and then update it. You can update it in a very ORM-like way. Now, an ORM also gives much more functionality on top of that. And I guess that's, that we're always looking for integrations and improvements to sit on top of our client SDKs in order to integrate better with the ecosystems out there for each language. But yeah, really interesting point there about ORMs. We've got a question here from Miguel. I don't know if you want to take this one, Maxwell. He's saying, in terms of security, could you discuss about how the Python integration impacts the overall security and data integrity mechanism of SurrealDB?
Okay, yeah. So this is another reason why we wanted to move over to Rust, basically running on the client, and that's essentially like the Python object literally is there so you can call it, but directly under the hood it goes for a PY03 binding into the Rust, and then it goes directly to the Rust. So your logging goes directly to Rust. Everything else goes directly to Rust. So it's just as secure in this sense. The connection that you hold then gets kind of wrapped in a Python object that's declared in Rust, and then your Python object then holds that. You can't directly call it because it's kind of wrapped, and then that gets passed back in every time you do a transaction. So it's pretty much all handed over to the Rust client.
That's interesting. So all of the benefits that you get from SurrealDB as we improve the performance, improve the functionality, all of that will be available to Python easily as we upgrade the Python SDK. Awesome. Perhaps we could jump in and demonstrate SurrealDB in Flask and look at some of the tests that we're running. And I know you've got tests around Gunicorn as well, just kind of showing how that's actually kind of starting up a server and running these tests.
Yeah, so let me just show my screen. You guys see that? Okay, cool. So here, I mean, if we do a run, it's going to take a long time. You're just going to watch everything compile and build. But the documentation is also on the branch as well, and you just have to run the Docker compose. So here we have like a Flask app. As you can see, we support that, and we obviously import this. This here, I was just playing around. So this is on my local machine. I was trying to get RocksDB locally running, and it does. But I stress it depends on what connection you're hitting. It seems to be different instances of RocksDB on each Gunicorn worker. This isn't a fault of Surreal. This is just a limitation. So I will stress to anyone who wants to use memory or RocksDB, if you're using locally when you try and do development, you'll run it and it'll be fine because it's all running in one instance. But the Gunicorn workers or the WSGI workers, when you put it in production, will then create instances of your app, and it will depend on which worker you hit. You'll get inconsistency. So I stress RocksDB and memory, not for server use, for local use.
But before you carry on there, it's probably worth noting, because we haven't really talked about this specifically, that actually that Rocks connection there that you have, give me 1 second. Yeah, that Rocks connection you have there is actually storing data on the disk from within Python. It's not connecting to another database. It's actually that functionality now where we store the data on disk, and we can open the database file and query data and close that database. That is built right within Python. Is that correct?
Yes. So locally, if you're using Rocks, it will be it's an embedded database. So if you're using Python for some sort of intensive data process, like a data pipeline, or in my last job, we're doing financial loss calculations for NASDAQ. It all just runs on one server. RocksDB will be fine. It's just that if you, because it's local to disk, your Gunicorn workers will duplicate your app and distribute it over multiple workers. So that's why you get the inconsistencies. But that'll happen with anything on disk. It's not, it's not a specific flaw for SurrealDB. So yeah, you can see like we've got some connections. These are the same as you'd use it in Rust, apart from you just have this extra bit. But you can also have the functionality of using the namespace. You've also got the login, and you've got the create user, and these are just general tests. And then you can see that we run it here on the ports, and we open it up. So in terms of like, let's say a Docker file, if you say, I want to use this today, then we can actually, this is the wrong Docker file, sorry. We can actually do a 2-layer build. And what you can do is you can use the official Rust image from Docker Hub, and you declare that as a builder. Then you install stuff that you need. So obviously we need Python, we need the dev, we need the pip, we need the setup tools of the wheel as well, because we're going to be compiling something. We also need libclang, because this is what's used to compile the RocksDB engine. And then we have our work directory. Then we copy some stuff over, and we've got a Docker ignore, but this is isolated, so we won't need it. We've got our thing here. You can see like our actual surreal.py. So that's something that you clone from our GitHub library. Then we do pip install, and then it would use Rust to compile the Rust bindings and all this sort of stuff. And then we do the second layer, which is kind of like you get a new image. So that means that you don't have Rust in that image. You do your installs again, and you can see that we install Flask and Gunicorn. We do a work directory app, and then we copy our distribution packages, which is what we built in the previous build, and we copy them over. Then we also copy over our app files, which is our Flask server and all this sort of stuff. Then we use Gunicorn, with a timeout and that sort of stuff, and then that's production ready. So yeah, that's how you do your 2-layer build. So if you're local development and you want to test out the Rust infrastructure, the Rust thing, again, I stress it's unstable, but if you've got Rust installed locally, you just do a pip install and you point to the GitHub repo, and that's fine. And if you want to put that in an app, you do this 2-layer build. And then your Docker Compose, we've got the Flask app there, but then also if you want to use SurrealDB, you just kind of use you have to have the environment variables set as these, and it will kind of help. Then you can log in as root. You can configure it how you want, obviously, but this is a bare bones on how you'd actually start it.
So that's actually, that example there is actually starting a SurrealDB server and connecting to it over WebSockets or HTTP, but you don't have to do that. You can run that right within Flask, within Python if you want to. So we've got a question here from LinkedIn, which is, what about ThaiDB? And what would be the supported way? Is RocksDB the supported way? I guess the answer to that question is RocksDB is kind of the default way. We do have plans to improve and switch out RocksDB in due course. We're working on our own embedded key value store written entirely in Rust, which should solve some of the issues that we're seeing now with just compiling this and building all the different versions for all the different environments. But effectively, SurrealDB is running within Python entirely, and so functionality with regards to calling FoundationDB or ThaiDB as a backing store is definitely a possibility. Probably more complexity as it uses gRPC to build C bindings into the ThaiKV layer, but it is definitely something that's possible.
Yeah. Also, just stress the fact that you have the flexibility of like just using Python as a connection to the database, or using the database in Python. And
Yeah,
so if you want to run a distributed SurrealDB cluster and just connect Python to it, you can do that. Or if you just want to embed Python in your script, you can also do that.
awesome. So, Alexander, a question for you: what is the what does the future roadmap for the whole ecosystem around our new Python library look like? What are we looking to add, or how are we going to be making it improved kind of journey for people getting involved with the Python library?
Yeah, exactly. So we have been working a lot on these kind of like foundational bits in terms of like getting everything up and running and making sure that they are performant. But what's kind of like coming up in terms of like the whole ecosystem is that we want to have like more kind of like templates out there. So for example, people like using Flask and Fast API. So it's like having kind of like starter templates for that. And then we're also going to be having kind of like demo applications built using those. So you'll be able to see in kind of like a real application, like how things work. And then of course we have kind of like tutorials coming up both in text and video form. So those are all kind of like in the works.
Amazing. Just looking through if we've got any more questions from the community. Not at the moment here. So yeah, anyone who's watching in, feel free to add any more questions, whether that's regarding Python or the ecosystem around Python, or maybe the new bindings that we've got with Rust. Miguel said, "Love heart." Just bring that up on the screen. There you go. So looking forward to that. We're really excited about this new integration. Obviously, the Python ecosystem is massive, especially with regards to AI, machine learning, and data science as a whole. So having this native, really kind of high performant, highly reliable integration that works right within Python, not as an alternative to running SurrealDB server itself, because obviously you get additional benefits when you're running entirely in Rust, but as an alternative, if you have needs around querying your data right within Python, maybe it's an instance that's short-lived, maybe it's for caching, maybe it's for machine learning or data science, and your data never really needs to leave the process that you're analyzing the data in. It's a really interesting direction we're going.
And also, oftentimes you have like when we're talking about like big data. So if you had like petabytes of data, you wouldn't want to transfer that out of the database into memory because it's too big to fit into memory. And so having access to that kind of like database is also something that is pretty cool.
Awesome. I guess, is there anything else that you think the community should hear about or should know about with regards to Python and everything else we're working on at the moment?
I guess what would be good if people, because we already have people that are building stuff on Python, and we have the awesome Surreal repo for kind of community projects. And if people wanted to contribute, say like a starter template for their favorite Python framework, that would also be highly appreciated.
Awesome, that's great. So just to add to what Alexander said, if you've got any suggestions or feature requests or anything else, then whether that's regarding Python or anything else that we're building, jump onto our community page on our website, and there you can see links to many different channels through which you can communicate with us, whether that's Discord, GitHub, Twitter, LinkedIn. So definitely jump on there. We're always open to suggestions, feature requests, and ideas, anything like that as well. Before we go, also just worth mentioning, if you're in London on September the 13th, we're launching our version 1 production-ready version of SurrealDB. We've got some exciting announcements, new features that we haven't yet discussed about, and that will be also streamed online at surrealdb.world. So if you're in London, if you can join us online on September the 13th, we'd we'd love to see you there. Other than that, Maxwell, really exciting stuff. What is the most exciting thing that you think we're going to be introducing with this new library?
I think it just kind of like opens up a lot of very performant things out the box for Python devs. So obviously you've got a database and you can make connections to that and make queries. That's cool. But the memory or the RocksDB is also extremely powerful. So some of you may have known that we actually implemented full text search. So essentially you have embedded full text search for Python with this, and it runs in Rust. So that in itself is really cool. And then all the extra features that would just keep coming. It's just a very powerful engine written in Rust that you can just call locally from your Python. So I know a lot of academics, a lot of data scientists, that sort of thing use Python. And I think we're also going to have quite a big impact. It's a big check I'm writing here for academics who are doing all sorts of research because they use Python. So if there was academics who had to search through papers or something like this, they could just write a script that would stuff it all into an embedded SurrealDB instance locally, and then they could actually implement full text search using Rust engine to sort out their results, which I think it's pretty awesome.
That's another interesting use case. I think we're going to leave with this, which is every single time I ask somebody about another use case that they see, or another something exciting way that this can be used, a completely new method or way of working comes back, and that's one of the most exciting things of what we're working on. I'll leave the audience with this comment from Miguel on YouTube, which is, this is changing the impacts of developers' lives, and it's really exciting to be working on tools that developers are loving to use, even whether that's you just starting out in data science or starting out in programming, or whether you've been doing this for 20, 30 years with data. What we're looking to do here at SurrealDB is make your lives easier, better, and enable you to do new things in more wonderful ways. And Alexander, thank you for talking about Python and for demonstrating some of the things you'll be able to do with the Python library. That's really useful, really insightful. Maxwell, thank you again for joining us. Really excited for the Python library integration with Rust. I think the community will be really excited as well. I think probably in this stream we haven't really even touched on what can be done. The community always finds other ways that we haven't even imagined. So really excited for that. Thank you both for joining us, and to the community, thanks for watching. We'll see you again soon.